So here we have a question on polar coordinates. We're told that figure 1 shows the design for a tabletop in the shape of a rectangle ABCD, and the length of the table AB is 1.2 meters. The area inside the closed curve is made of glass, and the surrounding area, shown shaded, is made of wood. We're told that the perimeter of the glass is modelled by the curve with polar equation r equals 0.4 plus a cos 2 theta, where theta is in the range of 0 to 2 pi, and a is a constant. For part A, we've been asked to show that the constant is 0.2. So the first thing we'll do is we'll draw the initial line. We'll have a pole at this point, and then we'll have the initial line where theta equals 0, given here in blue. And this is half the length of a rectangle, so this is 0.6. So we know then, when theta equals 0, r, given by this equation, will be 0.4 plus a times the cos of 2 theta, but theta equals 0, so this will be the cos of 0. So r will be 0.4 plus a times cos theta, which is 1, so plus a. And we know this r is 0.6. So therefore, a must be equal to 0.2. Okay? Part B, we're given that AD is 60 centimeters. I'm going to write that as 0.6 on the diagram here. We've been asked to work out the area of a wooden part of a tabletop, giving our answer in meters squared to three significant figures. So we're given in the formula booklet that the area will be 1/2 times the integral of r squared integrated with respect to theta. And because we're going to rotate all the way around, the limits are going to be 0 and 2 pi. So if we substitute r into here, the area is 1/2 times the integral between 0 to 2 pi of r squared, so 0.4 plus 0.2 cos 2 theta, and this is all squared, d theta. So now we need to expand this out. So we'll have 0.4 squared, which is 4/25, plus 0.4 times this, and the same again, which gives us 4/25 of cos 2 theta. And then we need to multiply the 0.2 cos 2 theta terms, and this will give us 1/25 of cos squared 2 theta. So it is this which we have to integrate with respect to d theta. And to make this simpler, I'm going to pull out the 25th in front of the integral sign. So the area will be 1/50th. Then we'll have the integral between 0 to 2 pi, 4 plus 4 cos 2 theta, plus cos squared 2 theta. Okay? We can easily integrate the 4, and we can integrate this quite easily. We need to use the double angle formulae to help us integrate this. So we know cos 2 theta will equal cos squared minus sine squared. If I just write this as c2 theta to make the notation easier, we want to make cos squared the subject, so we'll have cos 2 theta will equal c theta minus 1 minus c theta. Then we'll expand out this negative, so c2 theta, this will become a plus, we'll add it to c squared, so 2c squared minus 1. So we get cos 2 theta plus 1. We'll divide up both sides by 2, so we get 1/2, and that will equal cos squared theta. But you can see here that we've got 2 theta, so we'll double this angle and we'll double this angle. So cos squared 2 theta will equal 1/2. Then we'll multiply out these brackets of cos 4 theta plus 1/2. Then we'll substitute this into here. So this becomes 1/2 cos 4 theta plus 1/2 d theta. And then we'll add these two constants together. So this becomes 9/2. Okay, so now we need to integrate this. So we'll get 9 theta over 2. When we integrate cos 2 theta, we get 1/2 sine 2 theta. So this becomes 2 sine 2 theta. When we integrate cos 4 theta, we get 1/4 sine 4 theta. So this becomes 1/8 sine 4 theta between the limits of 0 to 2 pi. Okay, so now we'll substitute in our limits. So we get 18 pi over 2 here, so 9 pi. The sine of 4 pi is 0, so this cancels to make 0. And the same here. And then we'll substitute in the 0, and each of these terms will cancel to make 0. So we get an area of 9 pi over 50 meters squared. But this is the area of this polar curve. What we've been asked to work out is a shaded area. So we'll find the area of a rectangle, and then we'll take this area away. So the shaded area will be 1.2 times 0.6 minus 9 pi over 50, which gives us 0.155 meters squared. Okay?